Today is a Plasma application workshop, making microtransaction on the Plasma chain. Please meet your mentor, Pong Cheecharern. So you will learn the basic of Plasma chain, how it works, and the use case from on a high level. I'm passing now to Pong. Pong, it's all yours.
Thank you, Elena. You nailed the last name there. Well done. So hello, everybody. I think I can see everybody in the participants list. It's already 8:13, so I think I'll get started. Elena, how much time do I have?
You will have 1 hour for about 40 minutes for the workshop and 20 minutes for questions, but this is a guideline. You can go on more if you want. Also, everybody, you are on mute, but you will be able to ask questions through chat. So there is the button in the bottom of your screen. Open your chat and send message to everyone. Okay, thank you.
Okay, yeah, I think I see everybody in the chat. That's cool. Okay, so I think I will get started. So FYI, it's still 8 a.m. Bangkok time. So if I'm rather somewhat slow, that's the reason. But yeah, so today I'm gonna be exploring the application layer and the use case of the OMG network. So first of all, let me see if I can share my screen. Okay, so I think you should be able to see the Google Slides. And now let me, Okay, I can't present on Google Slides, but that's fine. I think I'll just go through the slide deck that I have. So for today, the topic is around making micropayments with the through the OMG network. So I'll just introduce myself first. So my name is Pong. I'm the product manager at OmiseGO. So I handle things that are more application facing. So as you know, the OMG network is quite low level. So I help facilitating and making informed decisions around APIs, integrations, external facing tools and libraries and applications and so on, with quite a focus on the adoption of the network, where developers are mostly concerned, because that's the background that I came in as well, as a pretty much a DApp developer. So that's a little bit about me. So for the topic today, we'll go through we'll start off with like a high level use cases. So what are the things that you could do with the OMG network? What are the things that maybe more importantly you cannot do? And we'll go not too deeply into the more VP Plasma design. So the FYI, the more VP design is the specific Plasma specification that we're going with the OMG network. And then the latter part, we'll explore some network architecture. So how does each component in the OMG network plans to fit in? And what are the APIs? What are the gotchas? What are the things that you as an application developer have to know about? And then last but not least, we'll end with a little bit about integrations and what you could do as an integrator, as a DApp developer, to start plugging in and start making transactions. The context of this workshop, I guess, is more focused around, it was more centered around like the hackathon, so the EDCON Hackathon. So if you guys are going to be attending the EDCON Hackathon, this should be somewhat valuable to you guys. If not, then that's okay. I think it's generalized enough that in the future, if you're planning to make an application or have use case for an application using a Plasma chain, then this should be at a certain level of value to you guys. So first explore some kind of like basic use cases and what I like to call non-use cases. So the focus of the OMG network, some of you may not know, is we are the plasma chain, and we are enabling micropayments. So if you have an Ethereum dApp that you would like to transfer funds over from like peer-to-peer transactions, then of course you have to pay the gas fee and the transaction costs, and that usually ends up being quite expensive. What we enable using the OMG network is that you can have micropayments, which means that you can make transactions with very little fees. Another use case for the OMG network that's being implemented is with games. So if you're tokenizing your in-game assets, for example, there's a game called Plasma Dog that's implemented by Horde. So something like that, where you have a in-game asset that are basically tokenized, and you would like to transfer between users. At the moment, I believe the token transfer only happens from game backends to kind of like the end users on our client side. And another exploration that you can have is around M2M. So not just peer-to-peer, you can have M2M, so machine to machine. I believe MBL chain is exploring something in this area, or having an IoT types of payments where you can have an actual device or an actual Internet of Things as an agent, and these agents can actually start paying each other. I think the pipe dream for like the M2M market is, maybe if you have a Tesla and you have an electric charging station and your Tesla has a wallet. So as your Tesla drives in and parks and charge, you pay, your Tesla actually pay for the electricity, not you that's paying for it. So that's quite fascinating as well. Or that might be some way away. So the more prominent use cases that we are exploring at OmiseGO is around points, or loyalty points to be exact. So if you have a company and if you have your own brand, your own products, maybe you would like to have a higher engagement. What you would want to do is you would want to have a loyalty point for your brand. In this current stage, most of the loyalty points are highly siloed. It's good if you're like a large, massive corporation and like really massive brand. You want people to just use your points. But for large, maybe mid-sized players, then you would want to have some kind of like loyalty points for your local businesses, and you want to an extent to make it interoperable with other types of points, right? And this is where blockchain comes in the sense that it's going to be much easier for brands, for companies, for businesses to be able to exchange points with one another if they are basically on the same settlement layer, right? If they're sitting on the same payment rail. So that's where interoperable loyalty points comes in, and that's quite fascinating. The next exploration that we are also exploring at OmiseGO is around exchanges. So exchange of values, quite similar to DEX designs or exchanges that you're normally using to maybe trade your Ethereum for OMG tokens or OMG tokens for SNTs and so on. We're not going to go too deep about exchanges, but we are exploring at OmiseGO a way to have a kind of like a hybrid between custodial and non-custodial designs that you can start exchanging your points or your tokens for different types of ERC20 tokens. Oh, so FYI, all the tokens that are sitting in the OMG network are all ERC20 tokens, but we will we'll dig deeper into that. And last but not least, kind of like my favorite is proof of existence. So if there's people that came in from the Bitcoin world, actually I find this quite fascinating, is because you can have like proof of existence is kind of like the first non-financial use cases of a blockchain, and you can do something similar with the OMG network soon, where you could say, oh, I have this land title, or I have this like digital art, so on, and then you basically hash it and you store it as a metadata on a data field on the blockchain. in your transactions. So you say, oh, okay, I have this piece of data, I've signed it, and I've stored it, and you can verify that it's me or it's this signature that signed it, and you can verify because it's part of the blockchain that this thing or this transaction happens. So proof of existence is quite interesting. Now to go to like the non-use cases, so the more VP Plasma specification is a UTXO based blockchain. So quite similar to Bitcoin and other UTXO based like cryptocurrency or distributed ledger. We don't exactly have we don't have like the same state transition that you would have in Ethereum or in EOS. So the smart contracts is kind of out of the picture here. There is no, I think we're not, doesn't mean that in the future there could be something quite basic as like something similar to Bitcoin scripting or multi-sig wallet, but in its current iteration, you don't expect to have any type of smart contracts or any sort of like logic that is sitting on the blockchain. And by the way, if you guys have any questions, you can feel free to ask them here, and we'll answer towards the end. Or if it's more relevant to the topic of discussion, then I'd be happy to answer here as well. So, okay. So that's the use case and the non-use cases. And I think if you are familiar with the kind of like the Plasma chain ecosystem, then you know that, oh, like, you know, there's a lot of different variations and different implementations of Plasma chain. And this, it gets quite hectic because I don't think there's best practice around naming convention in Plasma. You have people that come up with different flavor, I would say, of Plasma all the time. So this diagram was taken in, I believe, around late October or November 2018. So quite obviously, there's a lot more to be added to this diagram now. But as you can see, there's a lot. Like there's a huge variety that's based upon, you know, whether a certain type of Plasma specification is UTXO based, whether it is account based, whether it enables smart contract, whether it uses CK snark and so on. So I think in the context, I'm not going to go through too many of them, but in the context of what you can do with the OMG network and our Plasma design, it is a more VP Plasma design. So it's a variation of Plasma MVP that's authored by Vitalik. So we are right here in the left-hand corner. So Bai asked if you could download this PowerPoint. Yes, I think, Elena, can I put up like, I think at the end of the presentation, I can put up maybe a URL so for people to download.
Yes, please put it in the chat.
Okay, cool. Let's see. One moment. Okay, and I think in the end, we'll send a link to the slide deck as well, so that anybody that visits this video later could find it. But yeah, so that's kind of like the Plasma, different Plasma variations. So we'll dive into the more VP design right now. So there's kind of like three main places that I would go if I would like to explore, whether that is a specific implementation of Plasma or a specific implementation of the more Plasma more VP design. So for the, I think we'll go first with, we'll look at the ETH research first, because if you're not familiar with ETH research, it's where a lot of like the designs and discussions happen around different Plasma implementation. So this is a post made by my old colleague, Kevin Pitcher and Ben Jones, and it's focused around like the Plasma MoreVP specification and how it works and so on. I think it might be better to explain the kind of like what Plasma MVP is. So, and if you guys are curious, you can find the links here. And I'm just reiterating a lot of the stuff that's content that's outlined. And basically the Plasma MVP is the first implementation of Plasma, and it focused on UTXOs. So if you're not familiar with UTXOs, I recommend you check out, and it's consistent across a blockchain like Bitcoin. So if you have a ETH or ERC20 tokens and so on, it's denoted as a blob or an object of UTXOs. And for one UTXO, let's say you want to make, if you have like 100 token, you want to send 50 token to another user, what you do is you split that UTXO inside the shell chain from one UTXO to two UTXOs. And you send one to yourself, which is like the change that you want to send yourself. And you send the other value, which is the value you're trying to send, to the destination address. And that's a transaction part of the Plasma chain. Now there's basically three kind of major functions that you can do on a Plasma chain: deposit, transact, and exit. So with the deposit, most Plasma chains use a Ethereum or Ethereum-based networks as its root chain. So in this root chain, you can, let's say you have some ERC20 tokens. So let's say SNT, you can deposit. So you send the SNT tokens to that specific Plasma chain. And after a certain amount of time, that Plasma chain registers new events and says, oh, okay, there's a new token being deposited. So then after however many blocks, let's say 7 blocks, you can see the transactions. You can see the new UTXO emerges on the blockchain. Now, we're not going to go over, that's another part, which is quite equally as important, which is the exit and withdrawal process. We're not going to go too deep into that, but basically the kind of like the features that makes a Plasma chain more desirable to be used in application level, as opposed to a proof of authority, a pure sidechain, a pure proof of authority sidechain, is that there's certain higher guarantee that your funds will not be lost. So if I'm a single operator and I am running a POA-based sidechain, and you decided you want to bridge your tokens over to the sidechain, then I, as the operator, can actually take your fund, right? I could basically just lock it, and then you would not be able to exit your funds back to the root chain where you have this network security. In the context of Plasma chain and any kind of like variations of Plasma chain, you have this strong guarantee that there are somewhat complex exits and withdrawal process, and a lot of the kind of the research and the game theory happens there, which is how do we make sure that anybody and everybody can exit their funds safely without the chances of being compromised by the operator of the sidechain if they choose to be malicious in the end. So with the MoreVP specification, it's based on MVP, and the exit process is kind of similar, but with one less extra step, and we'll go through that too. So over here is the MoreVP documentation. So it's right here. So it's basically an extension of minimum viable Plasma, which I've already described. if you're familiar with that, then that's great. The only part that I would say is the differentiator between the two is around the exit protocols, and it's around confirmation signature. So with the MVP specification, every single time a user has to would like to send transaction to someone, a user would have to sign the transaction twice. So it would sign transaction once to send it, and once the transaction is sent, then you confirm that it's been added. So like another confirmation signatures. So this is obviously a poor user experience, right? And blockchain is already as hard as it is. So the MoreVP specification that is being implemented by us allows a user to just sign transactions once, so that we get rid of confirmation signature that you would find in MVP. And there is another kind of like key criterion in MoreVP scenario is that you can have an in-flight transaction or in-flight exit. So as you spend a certain transaction, or if you spend a certain UTXO, from a perspective of that user, maybe they don't have access to the block, right? Maybe a user is using like a really dumb client on the browser somewhere. So what they can do is they can basically, it allows them to still being able to exit that fund only after sending transaction and without seeing the block. And that's basically in-flight transactions in the nutshell. We won't go over to the, I think, the game theory of the in-flight transactions and exit games. I think that's somewhat beyond the scope of maybe the current discussions. But yeah, if you want to know more about the MoreVP design, we have a documentation in our Elixir-OMG repo as well, and you can give it a read. And it's pretty comprehensive. It goes over different transactions, how to make transactions, different exit games, different game theoretic scenarios. Okay, I think that's sufficient amount of info on the MoreVP side. And if you have more questions, you can add them into the chat as well. And I think Bai said that he cannot see the picture too clearly. Elena, can you see the screen fine?
Yes, I can.
Okay, I think I'll zoom in maybe a slightly bit. So, kind of can't do this. Okay, it's a little bit better. Okay, so for the next part, we'll explore some network architecture. So how the OMG network kind of works from a high level. And again, this documentation is part of the Elixir-OMG repo, which is where our production OMG network kind of live. So this diagram kind of explains how the different components and different sub-application works together. So if you go to the repo, you see that we have 3 key components to this. One which is the shell chain, and I think from further on, the plasma chain in itself would be considered a shell chain, and the root chain, in this case Ethereum, would be referred to as a root chain. And the part of the reason is that a plasma is a design spec, and it does not limit any uses of this design on any particular type of blockchain. So the shell chain can be different implementation. You can have different root chain that you would like to have a plasma, that you would like to enable plasma to have a higher scalability. So we'll look at this in the context of Ethereum for now. So let's say a user comes in, right? And a user decides to, I would like to use a plasma chain. So what they would do is they would come in here, and there are kind of 3, I would say, interfaces that they could have, whether they're interfacing through an exchange, or they could be interfacing through an e-wallet. And the e-wallet is basically a white label wallet solutions for enterprises to allow them to quickly tokenizing their existing or their kind of like point systems or their digital assets. So they can interact with Plasma through the e-wallet as well. And I think more so with the concern of the context of hackathon, in this case, it will be a direct user. So a direct user comes in, he or she would like to transact on directly to the OMG network. And if they have access to the watcher, so in this case, the watcher is a validating node, or I think of it as basically a full node, right? It's called a watcher, but it acts sort of like an Ethereum full node. So they could have access to the full node. Let's say they have a wallet already. They can interact with the watcher. And every single interactions that the user do, they only have to interact with the watcher, except if it's interaction with the root chain contract. So a user comes in, let's say he has like 100 ERC20 tokens, and this user is a classic example is Alice, and Alice wants to transfer, let's say 20 tokens to Bob. Alice would then call the deposit function, and the deposit function is right here as part of the root chain smart contract, the Plasma smart contract. And once she clicks on deposit and the funds are deposited into this contract, after a certain amount of blocks, the watcher would see that, oh, okay, the transaction is being included. So now the transaction is included into this shell chain. So, and the shell chain, as let's say as a direct user see that her transaction is included, she can then make a transaction to Bob. So she would call a function to submit transaction, and then that transaction would be transferred to Bob on the shell chain. And the moment that that particular transaction is included, the shell chain server would then submit block. So this is kind of like a quite an expensive operation. So that, but essentially each interval for each single batch of transactions that happen on the shell chain, it gets submitted. The Merkle root of that block is submitted onto the root chain smart contract, and once after a certain amount of time, and you have that finality, and you have that block included on the shell chain, on the root chain, sorry. And then after a while, let's say Bob and Alice make subsequent transactions back and forth, and Bob says, "Look, for some reason, I would like to exit my funds back into Ethereum. Maybe Bob doesn't want to keep transacting anymore, so he decided he wants to exit his fund. So what he could do is he could call the exit function. So the moment that Bob calls the exit function, he would go through a certain interval of challenge period, and this can be arbitrary, and this is configurable. So after this challenge period and has ended, and let's say there's no invalid transactions, and let's say all the implementation of the watches watches this specific function and say, oh, okay, Bob can actually, he should feel free to exit his fund back to the root chain. And then after that period, then Bob can call process exit and have his fund be sent back to himself on the Ethereum mainnet. There's some more documentation around how each components work, and if you would like to get into the technical nitty-gritty, then feel free to take a look at this doc as well. So I hope I'm not going too fast, and then the next part is it's more relevant, I think, if you're looking to implement or develop an application. And I'm also quite curious on the if you guys are watching this, on why you're interested in implementing a decentralized application, or what is your particular use case, or what is it that you're trying to achieve using the OMG network. And so feel free to add some ideas that whatever you guys want to hack on, or whatever you guys want to end up building, and I'll be happy to give you guys feedback during the hackathon and before that as well. So where the hackathon and where the application level things are concerned, we have client libraries. So the interaction with the Plasma chain and the interaction with the smart contract is somewhat low level. To facilitate that, we have a JavaScript client library, and that's in a repo called omg-js. And this is developed by Kevin Sullivan and I. So it basically is a wrapper around a lot of the functions in the more VP implementation, so that you could easily make a deposit, you can easily transact, and you can easily exit from the child chain onto the root chain. And because it's JavaScript, you could run this on Node, which is the server side. So if you would like to run a server-side application in Node.js, you could do that with this library. Or if you're more user-facing and if you want to build a client, a wallet for a user, you could also require just import the file right with the script tag. So if you're building a client-side wallet, then you could just bring this file, and then a user would be able to make all these transactions on the client side as well. And we have a few implementation. We have kind of like an example of how you would deposit, on how you would transact, kind of like a boilerplate code. So, this is like a simple process of how you would deposit. Let's say you have a Plasma smart contract and you have access to a root chain. You can set a few parameters and you can start depositing your ETH or your ERC20 tokens on the root chain, and then you can also start transacting that on the child chain once that is included. So if you are from a JavaScript background, I recommend you check it out. I think the only client library that we have right now is the JavaScript, but we could expect a little bit more in the future. And we are open to having some client library and integration library implementation be implemented by the community as well. So, that's, I think, more to come in the future. So if you're part of the hackathon, that is OMG.js is quite stable and it's quite ready to use. And to make life maybe somewhat easier, we've made what we call a JS starter kit. And this is more of like, if you want to hack around or if you want to get something up and running quite quickly, this is a pure boilerplate implementation of an OMG wallet on the client side. And when I say on the client, I mean on the browser. So that, the beauty of this is that it's in pure HTML and in pure vanilla JavaScript. So there's no framework, there's no dependency, there's nothing for you to install. If you just clone this, and if you have an instance of the OMG network Plasma, a more VP Plasma running, you could just take this, you can just clone it and then just run it on your browser. And if you have some ETH, you can just start interacting with the client side code. So no dependency whatsoever. And we'll dig a little bit deeper into how everything kind of works. So in this kind of like omg-wallet.js file is where you have everything you need. So let's say you have an instance running on maybe Ringbeat, then you basically put a Web3 provider, whether that's your local get node or that is on one that is on Ethereum. You can specify like, okay, this is where the watcher endpoint is, this is where the child chain endpoint is, and this is where my smart contract, the Plasma chain smart contract is. And the client side wallet should be able to quite essentially just query the UTXO for you immediately. And it has functions to create a key store. So without having to have dependency on MetaMask, the client-side wallet will create a public-private key for you based on your seed phrase. So if you just put a seed phrase, it will generate for you a wallet. You can restore your wallet from your seed phrase. and you can have a new address based on that seed phrase. It can also show your shell chain balances, so how much ETH or how much in tokens you have in UTXOs on the root chain, and you can see how much balance you have on the shell chain. And yeah, and there's a wrapper function around deposit. So if you just put in a value for a deposit, then it would just depositing the funds from the root chain onto that shell chain for you. And it's quite intuitive. And the same thing for the shell chain transfer. So once the fund is in the shell chain, you can start transacting, and this functions would generate everything that you need for you. I wouldn't say it's quite ready for production usage. There's a lot of more things, maybe security-wise, you have to consider. But as far as a hackathon, or if you want to try something out, or if you want to try calling API on the network, this is I highly recommend doing it through something like this, because your life would be much easier without having to install any type of dependency, without having to install any Chrome plugins, without having to install any apps, and anybody could start transacting. So that is a JS starter kit. It's already open source, I believe, and you could. I think right now, if you would like to run it, you could, but you would need like an instance of the OMG network and the shell chain. I think for now, you would probably have to install a local instance. If you go to Elixir, Elixir-OMG, we have a Docker Compose file. So if you're familiar with Docker, or Docker Compose, you can get up and running pretty fast by just running Docker Compose up, and then you can have a local instance of the OMG network. Now, if you are part of the hackathon and you would like to build something that is like an OMG application or a Plasma application, you don't have to be reliant on installing or having a local instance of that shell chain. Just for this hackathon, it will spin up an instance for you, so that each participant can just integrate to the same instance and be on the same network, and basically can put more time and focus around building application without having to worry about running this shell chain or having this shell chain operating. So yeah, and last but not least, we have what we call the ODP. So the ODP is OmiseGO developer program in an effort to incrementally release our new products. And for now, what may concern a alpha release. So we're currently running an alpha release of our network that is limited to people that is part of the ODP program and people that is part of our partners. So if you would like to integrate, you could basically join and you could submit it. A little bit about yourself and what you would like to do and your tech stack, and you'd be eligible for being part of the program, and you would get early access to documentation. You can get early access to boilerplate code and any types of products and toolings that will end up making in the future as well. So as part of this program, you get to interact with our engineers and myself included. So I think this question in the chat, is the OMG network the Plasma shell chain and Ethereum root chain? So if we look at let me see if I can. Oh, by the way, I think that's kind of like the end of the presentation. So if you have questions, feel free to ask right now, and I'll be quite happy to answer. So for this particular question, let me see if I can show you the network diagram again. I think for what the user is concerned and what the developer is concerned, the OMG network comprises of the shell chain and the watcher and the root chain smart contract. So maybe not the entire Ethereum, but I think the the kind of the encapsulation around what you would call an OMG network would consist of just that smart contract on the root chain, and there's two other external components. So not all of the root chain is part of the Ethereum network, the OMG network. Sorry. Yeah, if you have any more questions, or maybe not even have to be questions, maybe if you have like an implementation or an application that you have in mind that you would like to start hacking together in EDCON, or if you have an application that you're interested in making on what you're making right now, and if you're wondering if that design is compatible with the OMG network, I would be I'd be quite happy to give you guys feedback. Questions from the Chinese community. What are the differences from OmiseGO Plasma and other plasmas? So now that's, I think as you may know, that's quite a lot of plasma implementation. So it's probably larger than this diagram, and the OmiseGO's version of flavor of plasma is right here. It's called more viable plasma. So there are many plasma specification out there. I think Loom Network is doing a really good job with Plasma Cache, and there's a lot of. I think Plasma Group is doing a really good job with as well with I think their implementation is Plasma Cache with that, and then eventually they'll go into building. I forgot the name of, but yeah, I think for what you're concerned with, the key differentiators between varieties of plasma is in I think kind of like two or three things. Whether they are UTXO based, so if they're either UTXO based or they're account based, and the second factor is whether they are supporting a fungible or non-fungible token. So for more VP Plasma, I think it's written in the white paper as well that we would like to have an exchange or decentralized exchange built on top of that Plasma. For that exchange implementation and for that value transfer kind of implementation, you kind of need to have a UTXO where you are able to easily split between a large UTXO and a small chunks of UTXO. Or if you are able to split or merge a bunch of UTXOs together. So you want to have this flexibility of how you would like to transfer your fund. In the perspective of Plasma Cache, I think right now the focus has been quite a lot on ERC20 tokens, which are considered non-fungible. So if you have a single value or single unit and you're not looking to partially spend or partially split it and merge it, then I think Plasma Cache is a viable solution for that use case. If you have an exchange or if you're building peer-to-peer payment or simple transactions, then I think in this case, the more VP would be quite a better fit. So next question, what are the differences from, okay, are you part of the Lightning team as well? What are your process of the Plasma research now? As I recall, I don't think we're part of the Lightning team. And I'm not sure what you mean by Lightning. If you're referring to a Bitcoin Lightning network, then I guess the answer is no. However, I think one of the our advisor and the person that wrote the Plasma white paper, Joseph Kuhn, is pretty kind of ingrained and involved in the Lightning team. So that might be why you think we're part of the Lightning team. So in the context, in the question of whether what is the process for the Plasma research, I'd say we kind of move on quite significant. We make quite significant progress on Plasma research now. To the point that right now we are more focused on implementation. So if you look at a kind of like a deep tech scenario of like a life cycle of software development, If you have something that's like highly unknown, then you want to start with a research process, and then once after a certain cycles that is done, then you focus on the implementation. And I think for OmiseGO, we are focusing on the latter. So we're implementing, we're taking the design and the research that's being done by Kevin Fisher and by David Knott, and we're actually focusing on productionizing and implementing that. So we instead of answering questions around whether this could work, whether this is game theoretically like secured, whether a design for this is sound. Right now we're kind of answered all that with our more viable plasma. And right now the questions that we're trying to answer is that, are there blocks to be resolved? Are there issues on the networking layer? How's the latency going? What kind of like throughput can we squeeze out of the application by optimizing a few factors? So that's kind of like the things that we're tackling right now, and these things are post-research process. So we're to answer your question shortly, is that the plasma research for us for now is basically being done, and that doesn't mean that it's excluded any type of further research in the future. I briefly mentioned that we do not support smart contract. We do not support any type of scripting or multi-sig wallet as of yet. So if there are any other research, it might be happening on that front instead. So there could be more in the future. But for the next few months, I don't think there would be that part is quite done. Will there be any, next question is, will there be any hackathon for OMG in the near future? I think we'll have one for sure. It's not OMG specific, but we're going to be part of EDCON. So and so expect to see us in April, around the 8th to the 10th. And I think there might be more that we're planning in the works as well this year. So I would say do expect like a couple more perhaps, but nothing's too set in stone yet. If you would like to be more aware of what's going on and whether we'll have any hackathon in the future, I think when we have that solidified, we'll put that on Twitter, or we'll put that on our newsletter. So stay tuned for that. The next question is, if I'm a small business, how could we use the OmiseGO product? That's a good question. If you are a small business and you're not looking, it kind of depends on your definition of SME. If you look at an SME as a not too technically illiterate users, someone who would like to send transactions around, they would not need to know that that they're using any OmiseGO product, and because the OMG network and the things that we're building is quite lower on the tech stack, and the user is right here. So there's like gaps in between for people to make middleware, for people to make application layer, and as far as a small business may concern, they don't even need to know what is being implemented as their payment rail, right? The same way that small businesses, when they do remittances, they don't have to understand how their banks are wiring their money, or what kind of like protocols or messaging protocols that these interbank communication would kind of need, right? For their concern, they're using an app and they're sending value around, and they can see that they get email confirmation and things that are revolved around the application layer, but their interaction with the OMG network is quite minimal. And let's say if they are a certain brand, maybe they're an e-commerce business, they could be using the e-wallet. So with the OmiseGO e-wallet, we're somewhat more enterprise, more consumer facing. So if they are that brand, maybe they're using our True Suite. Maybe they are using an implementation of a white label e-wallet design, or a white label e-wallet code base. And yeah, I think that's that probably answer your questions. What's a TPS now? Good question. And I think we get asked that quite a lot as well. I think TPS is I consider TPS kind of a halfway between vanity metrics and actual meaningful metrics. And the reason I say that is because people claim that they make a certain throughput, a certain amount of transactions per second, while without disclosing how they come up with that number. And if you're looking to test how much throughput or how many transactions per second you get out of a certain implementation, that kind of numbers could be misleading depending on what you're testing or what specifically you're benchmarking. I think internally we are looking at trying to implement a more realistic benchmarking that we could do when the network is out there. And as far as that is concerned, I believe we're ranging in the thousands for our proof of authority implementation of the blockchain, not going to proof of stake, and that should be in the thousands. I'm kind of hesitant to give the number on the upper bound of that, but I think it's safe to assume that for a use case that requires maybe 1,000 TPS or more, it's quite safe to use OMG network. When and how could small business connect with OmiseGO using the e-wallet? That's a really good question. I think for the e-wallet team, the sprint cycle for this quarter is emphasized on the Ethereum integration. So for those that are not familiar with the e-wallet, it allows you to create tokenized points, whether that is on a centralized database, basically like a ledger on like PostgreSQL, and you're also able to do that and then mint these points on Ethereum on the root chain, and you're also able to mint and transfer these points on the plasma chain. So I kind of see the e-wallet as a 3-layer solution. However, with the focus being more customer facing, being enterprise facing. So we have like an admin panel, so you can easily make transactions on this particular ledger, on centralized ledger, on the root chain, which is Ethereum, and on the child chain, which is the OMG network. So the current progress of the e-wallet is that I think we're right now on the Ethereum phase. So we're looking at our integration with Ethereum and what that could look like. So I would expect within a few months that there would be, if you're working predominantly in Ethereum, that could be things that you can start connecting with. If you're a small business and your requirements are such that you require really high throughput and a lot of like micro transactions and so on, I would probably suggest you wait until we have a Plasma integration that you could integrate to. So I hope that answers your question. And I think the e-wallet Kanban board is public as well. So if you Google waffle board, OMG or OmiseGO e-wallet, you should be able to see what are the things that are in progress and what are the things that, what are the feature sets that are in the backlogs that will be tackled next. Next question. Can you explain the product in a real use case? When will the product release and the product release plans? The first question is interesting. The latter sounds like when released or when public or when internet. I'll try to answer the second question first, which is around the product release. And with the current release, we are in. I think we sent a newsletter last week about RE, which is our alpha release. So that's limited to people in the ODT program, OmiseGO developer program, and internally within OmiseGO and with the existing partners. So in that specific scenario, we're looking at getting rid of all the bugs, solving networking issues, making sure people integrate, making sure that there is a certain quality of usability for the developers, so that they don't struggle, making sure that there's a high level of uptime, and then making sure that we could scale the applications to a certain amount of users. So that's kind of like what is in the works. And the next step that follows that, it would be a beta release where it's kind of like open to people to join in. And that's what in the works. And that's our release plans. When mainnet, I can answer that. So can you explain the product in real use case? So a real use case would be something that I mentioned earlier in the beginning. So use cases around games, micropayments, a scenario where you need like a really high throughput transactions, exchanges. But that could be more in the future, but these are the things that we narrow down to as far as the business, small business, a small enterprise use case. I could see that they would be interested in the e-wallet engine and using the e-wallet engine to mint loyalty points or coupons and so on. It's kind of like asking what are the use cases of like double-booked accounting, right? Well, you can keep things in a ledger, but what are the use cases of like ledger? It's quite limitless. It's depending on like what you would like to keep an accounting of, or what you would like to transact. There's a wide variety that you could go over without needing complex smart contracts. Just join the ODP program. Hope you can try the alpha release as well. Thank you. Yeah, hope to help you get your hands on the integration and the integration libraries, and I'd like to hear more from your perspective as a developer, what could be improved or what is your roadblock, and ideally make that integration story a little bit easier. And I think the ongoing trend with blockchain development is that it's quite hard, or it's quite a number of steps that you would have to dig into through if you are a developer. So a lot of the ODP program for the developers would be to kind of like being able to navigate what are the things that that could be improved, what are the things that you could do to have like a life of a developer slightly easier, or helping somebody make an application, or helping someone building meaningful uses or getting meaningful uses out of the OMG network. So yeah. I think that's all. Okay. I'd be happy to take one last question. Would the product support non-ERC20 tokens as well? Good question. In its current form, we're not supporting. We're definitely not supporting non-fungible tokens, so we're not supporting ERC721. I think if you were to fork the code base and implement a feature that enable different types of ERC tokens, it could be viable, but then there might be some serious like auditing, some serious testing works to do. With that said, if you have a ERC20, a derivative of like ERC20 types of contracts, I think one example is like ERC223 that is backward compatible with ERC20 tokens. It would be viable. It could. I think the smart contract would support those kind of tokens, given that it's backward compatible and it shares the same interface with those tokens. But I wouldn't be too quick to come up to that conclusion. Maybe explore that a little bit more, making sure that there's no bugs or no issues. So yeah, I think that's it, Elena.
Okay, thank you, Pong. Thank you very much. So Pong is the product manager of OmiseGO, and he was talking about making microtransactions on the Plasma chain. Our next workshop Let me share my screen. Next workshop will be from Luke Anderson, co-founder of Sigma Prime, about anatomy of a client. Just remind you that you can sign up for the EDCON Hackathon at edcon.io/hackathon. And here you see all the social media and everything. Please follow us. And this workshop was brought to you by LinkTime and CryptoChicks. And hope to see you all at EDCON on April 8th in Sydney. And thank you very much, Pong, again.